Hi everyone, Krishna this side. So I am going to create a playlist regarding this recursion. So we will start with the basics and then we will reach into this medium level problems regarding the recursion in this particular playlist. So yes, at the beginner level, everyone faces a lot of issues with the recursion, but yes, we will make sure that this playlist will help all of them who are struggling with the recursion. And yeah, in this particular video, I'll be just covering what are all problems that I'll be going to cover in this recursion playlist, and some basic idea about recursion is what I'm going to provide in this particular video. So yes, stay tuned with this playlist, and once we cover all these problems, I'm pretty much sure that you guys will get some confident about this recursion and can easily solve any recursion problems. Once we are done, we will start looking into the trees problems, and before solving the trees problem we should have some strong grip over the recursion. So yes, I'll be covering this recursion topic in this particular playlist, and yeah, just let us look into this recursion. Okay, this particular image that I have created for you. So basically what is recursion, right? So recursion is a function call when it calls itself within the same function. Okay, so yeah, normally when we think about a particular code, let us look into this one. So getDiff is a function which has been called from somewhere. Okay, the moment a function has been called, we go inside there, we start executing the code line by line, correct? So here inside this function, we are calling few of the functions, right? In the first line, there is this addition function has been called. So it goes and check where is the addition function, and it do some processing, whatever it has been there inside there, and if we are returning something, it returns back into the same function. Since here we are returning integer value of this whatever the values that the params that we have, a plus b, that is something what we are returning. The moment we get this return from the function, it basically done at that place and it goes back into the previous function where it has been called, or yes, the area where it has been called. So this has been done. Since it has been written, now in the sum, whatever the sum that we got, a plus b, that is been stored. Now this line has been executed, the code starts looking into the next line. The next line is basically subtraction. So again here another function is something what we are calling, correct? So it checks where is the subtraction function, it go there and it try to solve whatever has been there inside there, and the moment if it is returning or we are end into that particular function, it return back into the previous function, correct? So yes, that's how things works. And once these two lines executed, the third line whatever has been there, that will start executing. So here in the return we are subtracting this sum minus sub, correct? Whatever the values that we get. So normally that's how the code flow works, right? So in the recursion, same thing happens, but we are just calling the same function within the function. Okay, how it has been working. Okay, let us look into this one. So in this particular video, I am not going to cover in depth, but basic idea how recursion works, that is something what I am just giving you the idea. So yes, if we look into this one, okay, we have this factorial function. Okay, we are trying to get a factorial of a number. So you guys will be having idea, right? Like how factorial of a number works. So if they asked factorial of 5, so it will be like 5 into 4 into 3 into 2 into 1, correct? Let us suppose there is some n value we have given, and currently n is basically 3. Let us just consider this. There is this function factorial, it has been called. So yeah, we have to think that how the factorial of a particular number works, right? So as I already said, factorial of 3 is like 3 into 2 into 1. So what we can think is like, let us try to solve this particular one in with the help of recursion. Okay, let's just give an idea about like how this can work. Okay, so we have a base condition here, and this really necessary whenever we try to solve any problem with the help of recursion. Okay, there should be some condition, some boundary conditions where at the moment that condition hit, it stop the recursive call further and get back into the previous one. Okay, so there are really necessity about these base conditions, and I'll give you in detailed explanation in the next videos. And when we solve all those problems, yes, you guys will be having understanding about these conditions. Okay, why it is really necessary. So it will check into this first condition. We are not entering into this one because n is basically 3. So it try to execute the next line. In the next line, what you have done, there is n, basically n is basically 3. 3 into factorial of 2. Basically, n minus 1 is basically 2, right? So that is something what we are calling. So what happens? This factorial of n minus 1 is similarly like here we are calling different functions, but in this particular one we are calling the same function. Correct. So that's how things is happening right over here in the recursion. Just instead of calling different functions, we are just calling the same function from the same function itself. So, okay, what happens? It will just check that where is the factorial of that function is been written, and it goes there. It just passes whatever the values that values we have been passing right over here. So we are passing 2, correct? So it will just have that same function in the call stack. It goes there and it try to process again inside there. So the first condition definitely it will not meet. So n is basically 2 in this case. And next line we'll start looking into this one. So n into factor of n minus 1. Correct. So here again we are passing n minus 1. Okay. Now this factorial of code is something what we have to execute. Correct. See, we won't be returning from any function until and unless we finish that particular line, correct? So until and unless we are done with this particular one, we are not returning back, correct? That is how these things work, right? If a job is not done yet, how we are expecting that it will go back, correct? So yes, we have to finish this particular part of the code. Now factorial of n minus 1, again this same function has been called, so again it goes there and checks where is the factorial of the code. So here n value is basically 1 is something what we are passing. Now if n is basically equals to 1, we are returning back. The moment return is been called, we are not going further ahead into the code. So we are stopping, we are avoiding here the recursive calls that we are doing, right? We are just stopping it right over here, correct? So that is really base condition is really important. That's why, because we don't want to keep on calling the function again from the function within the function, right? So it will definitely hit stack overflows and all. Okay, so base condition is really necessary. So the moment we say that if n is equals to 1, we are returning back there. So here it is basically returning 1 into this particular value. Okay, n was basically 2. 2 into 1 is something what it returns back to the call where it has been called, from where it has been called. So here it is like 2 into 1 is basically 2. 2 is something what we are returning back from this particular one. Correct. Just think that these are different type of functions that we are calling. Just the new values are something what we are passing. Again, this particular code. See, same thing, right? This addition until and unless we are done with the addition function, we are not going further, right? That's how things work, right? So instead of sum minus sub, if I would have put here addition minus subtraction, these same functions right directly over here and storing their values into this sum and sub. Uh, I will try to first finish this addition, then I'll look into this sub. Until and unless this subtraction function has been done, we are not returning back anything right from there. So that's how things works here. Okay, so yes, in here it is returning back to, now n was basically 3. 3 into 2 is something what 6. That is something what we return back wherever it has been called. So that's how things works. Okay, it is pretty much straightforward. So we just have to imagine like how our logic is going to be built, right? In this particular case, we have to imagine entire the tree like structure, the flow that is going to it follows, and the base condition is really necessary. This whatever the base condition that we are applying here, right? And the values that we are passing, these values and this base condition should be some extra logic that we need to put is like in these areas only. Okay, in the recursion, because in the normally whenever if they would have asked to get a factorial of a number, we could have run a for loop from 1 till n and keep on multiplying with whatever the I value that we are getting and storing it, and at the end we can return it. But in the recursion, yes, we are dealing with the functions calls, and yeah, we are just trying to reduce the values and again calling the same function. And until and unless if n is basically 1, we are keep on calling those functions and returning back those values. Okay, so yeah, that is all about the recursion, and all the problems that we will solve, we will try to think and imagine like how the tree like structure basically works, this call stack. So from factorial of 3 we are calling to factorial of 2, factorial of 2 to, we are calling factorial of 1, and the moment we are reaching to 1, we need to return there. From there, from here we are returning 2 into 1, from here we are returning 3 into whatever the value that we got from here. So 6 is something what we get. The moment this is done, we are returning this function. So that's how things works in the recursion. So there is a note base condition. Whenever we are thinking, we have to think really logically. Okay, right over here. and whatever the values that we are passing, that should be justifiable with the base condition, so that at any point in time, whatever the values that we are passing, it should reach at certain level. Okay, so what if I would have directly passed a factorial of n instead of n minus 1? Again it goes, again it calls, and n value is basically 3. Again it come here, again it calls factorial of 3. There is no stopping at any point in time, right? Like we are continuously calling factorial of 3, factorial of 3, factorial of 3, and we are not having any base condition where we actually want to stop this recursive calls, right? So this is going infinitely, and definitely this will cause stack overflow at a point. Okay, so to avoid this, we have to really think the best possibilities about this base condition, where we actually want to stop, and what is the logic basically we want to write, correct? So yeah, that is all about this recursion in this one. So only thing is, like, we have to think about the base condition, and for the to meet that base condition, what is the logic that we need to pass into this same recursion function. Okay, so yes, that is all about this recursion. And in this recursive playlist, first next video will be like basic about the recursions, some basic problems, I'll solve with the help of recursion, and then we will solve these problems. These are medium level problems. In the next video, I'll be covering some basic problems, and we will definitely try to see like how this calls tree like structure basically works, and each problem will think about this approach only. With the help of this one only, we will get clarity about the recursion, how things works, and how we can go deep dive into this one. And yes, the moment we solve all these problems, we are pretty much confident with this particular recursion. Okay, so yes, stay tuned with this playlist, and thank you for watching this video. Bye bye.